If you are a Java developer or a tech lead, you must be already knowing the pain when your code review is done and you get a bad code review comments. Also, when you raise the PR, you are little bit frightened up to receive the code review comments by the seniors. Now, if that is the case, I will try to tell you what are the improvements you need to make in your code changes to elevate your Spring Boot code so that the next time you are going to commit, that would be the best code you ever commit. So make sure you watch this particular video till the end, because I'm going to explain you not only the theoretical part, I'm going to explain you the practical real world mistake every Java developer does, because that is going to cost you time, money, and also lot of struggling over there. So wait and watch. Let's start the video. Now we'll discuss the most common pitfalls in the code review with all the examples in this video. The very first thing is RESTful API design. Now if you are a Spring Boot developer or a Java developer, you must have been asked by your seniors to develop the REST APIs. So some of our other code you must have definitely written. Now I am going to explain all the pitfalls of the code review comments which you must have received and how you can avoid it. Now, the very first thing what we are going to discuss about the lack of versioning. Now, what happens if you are not implementing the API versioning, which is going to make your future changes much more look difficult, because it will break your existing code which the client is using. Now, we'll tell you what exactly that you have done wrong over here, and then also I will explain you how you can improve in the code editor. Now, if you see here, there is one product controller over here. Now you see here, actually there are some versioning problem over here. Now you see there is no versioning and there is also no direct path given to it. So if you see, there is a REST controller defined over here, and also if you see here, there is also products defined over here. But if you see, there is no versioning defined over here, there is no direct path given into it. Now let us look into the way where you have to make it correct. So you have to implement the API versioning. You have to have the URL versioning or the header versioning. Let's look at that particular code, how you can do that. Now here, if you see, in against to the code which we have written earlier, there was no versioning maintained over here. You see here, there is a proper versioning maintained over here. So in this, you denote that there is a proper versioning is happening, so that tomorrow if you have another versions of code to be written, you doesn't have to modify or to to change the existing thing. You simply have to change the URL and the versioning, and then you will be simply redirected to that particular new code. Now let us try to look at the other option. Now if you look at this particular version of code, this is the version 2 to the version 1 which we have already discussed. Now this was the version 1, but here if you see, I have maintained another version over here. So this is how you can maintain the different versions. Apart from versioning from the URL whatever we have discussed, we can alternatively make use of the header versioning over here. So when you are trying to produce the result over here, you see there is also a versioning maintained over here. So in that case, you can actually make that particular version maintained over here. So this is one of the alternative way of maintaining the version over here. The next is poor error response structure. Now if you are dealing with calling the client API, what happens, then you are calling the API and then you are not showing the appropriate message or inconsistent message. Sometimes you get some other response, sometimes you get another response. There is no consistency maintained in the format you received as a response. So what happens, the client is frustrated and is not aware what input he has to change or what is going wrong, which is causing the server to return such errors. So if you take a look at this particular controller, you have the mapping returned over here, you have the path variable defined over here. Now if you see here, there is some validation is returning. Now you see the response whatever you are trying to do is sending the body as an invalid ID over here. Let's say that it is 0, then it is returning not found, the status as the not found, but it is returning some body as this. Now this is just a plain message, and this is not the right way to send the response. there should be a perfect format to and a standard format that should be followed across your application. So in order to make the consistency, I will define one class error over here. Now you should be adding all the structure over here, that this will be globally returned in the at the rate controller advice. So I will go to the controller advice. So this is the format, the standard format. What is the status? What is the error? What is the message? When did it occur? So this is going to be a proper formatted response where it will show you what exactly went wrong. Now, if you go to this particular global exception handler, you will see there we have written something like the controller advice. Now, this is one of the way to handle your exception wherever it is happening in the application in one location using the controller advice. So, this is quite important when it comes to dealing it. Now you see there is an controller advice annotation, it has been marked over here. Now this is where you define all your logic. So the controller advice, it is going to look out for all the exception which is happening at the runtime, and if you have written some advice over here, you will be able to handle it over here. So let's say and anywhere in the application the illegal argument exception is happening, so that will navigate to this particular exception method. Now if you see here as a response entity, I'm trying to send the response with the error response. Now error response is something which we have properly formatted, we have all the details. Now if you take a look at this, under this error response, I'm trying to capture the status, I'm trying to capture the string, the exact message, and then ultimately I'm trying to respond this with the status over here. So this is quite in a concise and a formatted way, and also the client would know what exactly it went wrong. So in all way you can actually handle for n number of exceptions. That's where you can actually deal with. Also just make a note, if you see there is an exception, so let's say you have defined certain exceptions, custom user specific things, and let's say it doesn't happen to be happening, the exception is not something what you expect. So you can have a common exception defined which will uh, catch up all the unexpected errors which will fall here, and then also you'll get a brief understanding. And also in this case, if you see, it is trying to return the internal server error. So internal server is nothing but 500 basically, or it is something which is related to the server but you don't know the exact cause. From the stack trace you can get to know what exactly is the root cause. Now if you look at the controller over here, now any exception which is thrown over here will indirectly come here only, and it will handle it over here. So that's where anywhere in your controller, your service or repository, any exception is happening, it will directly navigate to that particular thing, and then it will showcase you the error over there. Now then comes this synchronous operation for long running tasks. So if you have a requirement where you are calling some or doing something activities which is taking too much of time, and that is also done in a synchronous way, then that's a problem. Now let's take an example. Let's look at the example. So let's say you have a blocking client request that is doing some operation and it is taking a lot of time. So it is leading to a poor user experience also, and also the resource is exhausted over there. So let's try to take an example. Let us take an example of how we can actually solve this. The very first thing, we have to define the asynchronous processing using the async method and annotation. So here at the configuration level, you have to first make use of the at the rate enable async. So this is going to make your application run async. Okay, and then if you see, I have written the async configurer over here, and then I'm trying to execute some task over here to complete that. So this is going to enable that async support for your application. Then let's look at this service level thing. So whatever the things changes we have done here, apart from that, this will be running as a separate thread over here. If you see this particular method, whatever the logic I have written over here, I have marked it as an async. So this, if you write this two annotations, the enable async and the async, then you will be able to achieve and run that particular code in a separate thread. So this is how you achieve asynchronous communication, or asynchronous tasks would be completed in a separate thread instead of in a blocking way. So that's how you can make that particular changes and run it. Now the problems of with the DTO is that they are just the mirror entities with improper constructor, mapping logic and validation, so which could lead to a manual error prone mapping of the code to the entities. Let's try to look into the code. Now let me close all these things. I will open the user entity over here. Now this is going to be the manual and the verbose mapping whatever you are doing over here. Now in this, if you see, this is going to have the sensitive information. Let's go to the user DTO over here. Now we have the email, username and other details in this specified. So I've generated the getter setter. So here if you see, there is also a no password here actually, so we are not mapping it in the manual, so we are going to do the mapping manually over here. So in this, there is no password being mapped over here. Let's go to the service. Now if you look at this, actually I have this particular details find by user. It is being called up over here, find by ID, and I'm trying to get this particular username, ID, name, and I'm trying to manually map this particular to the fields over here. So that is what the manual mapping we are doing it over here. Now instead of this, you need to make use of the mapping library, like you have a map struct or a model mapper, which is going to be the efficient way to save the DTO entity conversion. Okay, so we'll look into that. As we mentioned, we need to make use of the map struct. So here if you see, I have been using this particular dependency added over here. This has to be added in your pom.xml, and in your code you have to add this particular mapper over here in the Spring. Then you have to define the user DTO over here, so that it can, the Spring can automatically map it to your code over here. Now if you look at this particular the other entities and the details would be same. There will be no changes like in the DTO and the entities. Now also there will be no changes in the DTO as well. Now if you go to the user service, so here if you see, I'm going to make those particular changes over here as a controller part. If you look at the service number 2, you will see that there are some details I have mentioned, like you have auto wiring of repository mapper. You see here I'm trying to inject that same mapper over here. Now if you make a note over here, I'm trying to make use of this mapper and map it to the DTO, the user. So this is quite clean and automatic mapping done by the Spring Boot over there. Similar is the case with the other method, where I'm trying to easily map it instead of mapping it manually one by one with the attributes. So this will be a quite time saver, and also a little bit in a concise way to handle your DTO mapping instead of manually mapping one by one the code. So let's look at the another one is configuration. So let's say if you have not done a sufficient externalization of your application. So let's say you have not defined environment specific configuration like dev, test, production for your build artifact. This is going to be a problematic because you are directly trying to add that particular configuration in the code itself. So that's one of the wrong way to do it. You see, I have opened the application.properties. You have defined that particular application name, port. Also, I've just commented it for showing you that it is a wrong way to do it. But ideally, you don't try to write everything in the application.properties, because this is going to be the general file. So you need to ensure that you are writing that particular property specific to the environment you are dealing with. So you have to create different production property files or the testing files based on your environment. In this case, what you have to do, you have to make use of the Spring profiles. So you have to create the application and the specific environment, then the property file name, so that the Spring Cloud config server or the environment variable is going to pick up that particular value from there. Now, if you look at this particular property file which I've created, and if you just notice that application hyphen dot prod properties, now this is going to be specific to the production related properties, and there is no way or no chance that you are trying to enable, show, or mistakenly use the other environment properties over here. Now, if you take a look at this, all these particular properties, whatever I've mentioned here, are there. Now, similar to this, I can create the dev property, the production properties, testing properties, and then you can use that. So that's how you have to use that. And when you're trying to run that particular application using the uh, jar file, what you can do, you can actually run it with the help of the java hyphen jar and your jar name, and in that particular command itself you can run the or enable the spring profile, the active profile. I'll just show you that as well. When you're trying to run your application in this way, you can actually run it your application jar name, and then you have to enable that particular specific profile so that it will pick up that particular properties from the respective environment properties. Then comes the mismanaging of the profile. So if you are not effectively using the spring profile that is used for different configuration for different environment, and this can become unmanageable, and it also become little bit cumbersome. It might happen that you are exposing your production details to another person so that he can manipulate that. So this is going to be a problematic. So what you have to do, you need to define the specific profiles, distincting environment properties, and ensure that they are correctly being activated when your application is getting up. So if you are not having the profile specific details written, then it can cause a problem while future. Now, dependency management. So let's say you are not taking the advantages of the Spring Boot dependency management. So it happens like you're trying to manually add the version of that particular Spring Boot version starter, or you're trying to manage your dependencies on your own. So what will happen? It will lead to an inconsistency. Also, there will be lot of conflicts, and there might be lot of errors when you're trying to do the application up and running in your environment. So let's say in an example, if you take it, you see here I'm trying to add the dependencies in the pom.xml, and you see I'm trying to add the specific version over here. Let's say for the JP, another thing. So it might happen your parent version is different and your this version is different. The starter dependency is different. So always don't try to add the version if you have added in the parent. So make sure, so in order to be in the correct position, always try to depend on the parent starter, or you can define in the Spring Boot dependencies of the BOM, where like you can define the parent with the specific version you want, and then rest other dependency can follow that particular specific same version over there. So in that case, you are not trying to add that particular version every time to test that whether it is working or not. Spring Boot will internally take care of that particular part. Then you're trying to mix up some Spring Boot managed with the unmanaged versions. Now what happens, you're trying to override the dependencies without you properly being understanding or testing it in your application code. So this can break your compatibility, also break your application while runtime. So let's say if you are defining the dependencies manually over here, let's say the Hibernate, if you see here, you're trying to manually add that along with the managed dependencies over here. So what you're trying to override the Spring Boot internal configuration. So here, instead of overriding the manual or the managed version, what you can do, you can let the Spring Boot handle that. You have to just define the parent over here, and then you can define the respective starter dependency like Spring Data JPA, which is also going to handle your Hibernate database related things internally when you define this particular dependency. So make sure you add the starters which are relevant to that particular applications or the API. Now let's take an example of the service layer. You have defined the services which is going to let's say you have defined some services and it is going to just act as an pass through to the repository, and there is no business logic in it. So services are meant to have the business logic, and let's say you have not written any logic, and the logic of handling those particular things are either written in the controller or somewhere which they shouldn't be written. Now if you take a look at this, you will see that we have a product services, and then you see it is simply returning it, that it is not doing any validation or certain logic. It has to be written in the service. Now ultimately the controller is going to take the load and then write that particular logic over here. So you are handling the error over here, you are trying to do some other activities like you're checking the null if it is written or not, and all other sort of validation things which you should not do it in the controller layer. So in order to do that, you have to write the logic in the services. All the validation and orchestration should be written in a different components. So here, if you see, there is a product services written over here. Under this, if you see, I am writing the business logic of validations. If I'm throwing something, there is some exception. I'm trying to handle some exception handling logic over here. Then ultimately, there is another method which we have written where I'm trying to do some complex a logic exception to be handled, and then trying to return things. So here if you see, they're all things, only the controller, if you see, this is just calling, it is you should delegate your call to the service, and the exception and everything should be handled in the controller advice. So this is how you segregate and write that particular changes. Now if you look at this particular fat services, now you might be writing one services where it is going to take a lot of load. It is trying to do n number of things in the single services. So instead of writing into a different domain specific or a single responsibility class, you try to do everything in one god object or god service, I would say. So here you see, you're trying to do create a service over here. It is doing the repository related thing, user related things, order related thing, email, sending email, it is going to generate the report. So this is one bulk service which is doing everything. Now this is what not the right way to do it. You have to write your specific smaller focus services so that it can do that single responsibility what it has to do. So in that case, you have to write that particular code. Let's say your user specific service you have written. So only the repository related things and the other services you have to write it over there which are related to it. Rest other things has to be written in the other services. Now if you see, there is an order service. The order service is being repository and written over here, and you can deal with the other interrelated things, but you have to segregate that instead of trying to create. Now email service, it's a separate service, the reporting service over here, so on. You can segregate those particular into different services and deal what exactly it is trying to deal with instead of trying to do everything in one single service. Now then comes unnecessary annotations or the boilerplate codes. Now if you are using transactional, if you have been using transactional, and if you are not using it in the correct way, or if you're trying to overuse it, then can be a problematic. So if you are applying at the rate transactional to all the read only methods, or you are trying to do too much granular level of every method, so this is going to cause more problems. Let's look at the unnecessary annotation and the boilerplate code. If you are trying to use the at the rate transactional annotation very everywhere, then that is a problematic. So if you are trying to apply at the rate transactional on the read only methods, or you're trying to add it on the too granular level at the every repository level where it is not required, it should be written in the higher level services where it is much more appropriate to write that particular code. Now if you take an example, I'm in the product repository, I have written this particular repository, and if you see, I have annotated with the at the rate transactional. Now this is going to be the unnecessary, as this is going to be the read only way. And then also at this transactional, if you see trying to save, this is also the redundant. So if service layer has the at the rate transactional, then it can be a right location. So instead of writing in the repository level, you have to write it in the service level. So here if you see, there is no transaction. So this is the appropriate location where you have to define that repository at the rate transactional for it. Now this is going to be taken care. Now if you apply that in different location, this is going to be a problematic. So service layer is the appropriate location where you do the actual business transaction, and that is where you write it. So you can use read only if your application is only performing the read only operation on the database, so it can optimize it. So in this way you can do. So in the repository you don't define those particular things. Okay, define everything at the read on in the at the rate transactional in the product services or something like that. So here it is, you can mark it as an read only, where you can make it as true. Rest, you can actually have the different methods also defined over here. Let's say you are doing some modification, you can define in the service layer itself, or you're doing some complex, then actually you can return in this way. Now you're trying to manually handle the boilerplate code. Now let's say you're not taking the advantages of the Spring Boot auto configuration. So let's say you have some common task like embedded server is there, data source is there, JPA repository is there, and some you should have some redundant configurations and other things. So what you are trying to do is, as an example to take it, we are trying to manage the data source configuration, when auto configuration could take it as a very easy way. Now if you see, I'm trying to do the configuration over here. I've defined the beans, and I'm trying to do the all the password details and everything. I'm trying to map it, and then explicitly I'm trying to get those particular details in the JPA config, etc. over here. So instead of trying to do those things, what you can do, you can rely on the Spring Boot's auto configuration, that is convention over configuration. So we can make use of it this by simply applying the stride starters and the set properties you can define in the properties. So you have to just define those particular properties in the application dot properties, and then rely on the auto configuration features of the Spring Boot. Now if you look at this, there is no specific data configuration required or anything. You just have to add the starter dependency of JPA, and Spring Boot automatically create the configuration, the data source, the entity managers, and etc. based on the property files you have defined. So you have to just enable that things. Then comes, you are trying to interact with the database. You have the JPA repositories, you have the Hibernate specific code. Let's say you are not trying to deal the fetch type, or you're not trying to use that particular fetch type correctly. So let's say you are using fetch type as an eager, which is going to excessively do the association, and it is trying to overly fetch the details, and there will be a performance degrade over there. So if you're dealing with the entities which has got many relationship, then it's going to be a problematic. So always do avoid eager fetching, which is going to give you a problem. So if you see here, the order has got the list of orders over here. So it is trying to eagerly fetch the customer over here. So I'm trying to fetch the order. For every order, I'm trying to fetch the customers over here. So when you fetch an order, it will automatically load all the items along with the customer over here. Now this is going to have lot of internal queries being fired to the database. So instead of that, you can use the fetch lazy over here. So which is going by default going to fetch only when you specifically try to call that. Or else if you define that, let's say eager, then you can specifically write the query like join fetch in the JPQL or entity graph in the JPA. So this is going to lazily fetch that. So if you see, you can map the mapping over here and define the strategy over here as a fetch lazy. So this is going to fetch by default lazy only over here. So instead of calling it on the moment you try to get that, when you're trying to load your application, it will be called only when it is required. Or you can do some join fetch over here, which is going to, you can write that in the query annotation, where you define that particular query with the join fetch over here. Or you can use the entity graph, so which will override your default fetching strategy for this particular specific method. And then in the service layer, you can actually call this particular specific methods, and it will be loaded as per according the strategy what we have written. Now there are some lack of transaction management thing. Now if you are not properly defining the transaction boundaries, then there's going to lead to an inconsistent data. There will be unexpected behavior. So lazy initialization exception can occur when you are trying to access the lazy loading association that are out of the transaction. So let's say you're trying to define a service and the repository over here, and you try to see this is this particular line, whatever you're trying to do, can throw this particular lazy initialization if the item is lazily loaded. So this method is going to be called from the web controller without @transactional. So the session will already be closed before the trying to access that particular lazy association over here. So that is the problematic. So you can use @transactional so that your persistent context is available everywhere throughout your operation, and it can easily load the entities over there. So here if you define that particular service is over here @transactional, so that this is going to make sure that it is open until you are trying to fetch things. So there will be no extra work to be done over there, and then everything will be taken care over that. Then you're trying to ignore the DTO projections for the queries. What happens if you are trying to fetch entities? That is going to be only when the subset of entities needed. In that case, now let's say you are not properly managing the transaction management. So let's say you are not properly defining the boundaries. That is going to lead some inconsistent behavior. So like lazy initialization exception. So let's say here you have defined an order, and then inside this you are trying to do some lazy loaded things over here when you're doing this. So this will be already closed up, and then you're trying to access this particular things like that. So what will happen that it will throw a lazy initialization exception over here. In order to deal that, you can actually add the @transactional, which is going to be the read only, and then if you're trying to get some order also, it will work. It will not give an exception over here. So if you are trying to ignore some DTO projections in your query, let's say you're fetching the entry entities when you only have to fetch the subset of the data, then especially if you are doing some heavy operations, this is going to lead to a data transfer and object hydration overhead. So let's say if you are fetching the entity when only the ID and the name is required in that case. So here if you see you're trying to retrieve the full entity where you only require those two things, then this is going to be an overhead over here. So what you have to do, you have to use the DTO projection that is interfaced or class based along with a constructor or a query based DTO construction. So you can only fetch that necessary columns. Let's say you are using here the user summary over here. This is going to be the interface based approach. Also you can use the class based approach over here. You're fetching only those things which is required, and ultimately you're trying to fetch that only based on that information. So this is how you achieve that, and you can write the precise code. Then you try to do the find all on the last table, which you could have achieved using the pagination or the limitation approach. So instead of fetching all the records, which is going to lead to an out of memory error, or it's going to degrade your performance when you're dealing with the large data sets, it is going to be a problematic thing. So you have to deal it in a proper way and use the pagination over there. So here if you see you're trying to fetch all the records over here, say find all, and then you want to return it. But here instead of that you can use the pagination, where we have the Spring Data JPAs, pageable, and the paging sorting algorithm or the filtering things where you can use it. So you can use, see here, the JPA repository where you can actually have the pageable over here defined, and then you can use that in your application. So instead of loading all of them in certain at once, you can do pagination with some limitations of number of records and the limit by defining the page size and the page information and the size information. Now let's look at the security aspect. So let's say you have defining some weak passwords hashing over here. Now what happens, let's say you are using the outdated or insecure algorithms. Let's say you're using MD5, SHA1. So instead of using the modern day, that is bcrypt or argon, you're trying to use the old way. So in that case, this is one of the insecure way to have this particular authentication handled over there. So you have to make use of the Spring Security, the latest version, the modern way how you can handle that. There are password encoder, there are bcrypt password encoder which is used for password hashing over there. So you can define those in such way. You see here you have defined this particular in the security configuration so that you can make use of it. Then you're trying to hard code the secret code. So you're having an API key, some database passwords, etc., which is you are writing directly in the code. So this is the wrong way where you are exposing your sensitive information. So here what we can do, you can define some environment specific variables in the cloud config servers, or you can have a dedicated secret management service like HashiCorp is there, you have AWS secret manager. So in that case you can get it with the help of the @ value from the properties, and you can make use of it. Or also you can actually define in the configuration in any of this particular environment specific the product key and other details over there. So this is going to be much more a better way and the robust way to manage using this particular tools. Then you are having the insecure default configuration. So you are not changing your default credentials. You are not you are trying to expose the endpoints like HRA endpoints for the production. So in that case you have to limit yourself to specific things. So here you see in the properties you're trying to expose all this depend endpoints to everybody. So instead of that, you have to limit your actuator endpoints. You have to add the security. You have to change the default setting. So in that case, you are trying to only expose the health and the info related things. Rest other things you are trying to exclude those things. So you're trying in a way you're trying to have that proper control over what is should be accessed and what should not be accessed. Then comes logging and monitoring. Let's say you are having a poor log structures maintained. So there will be an inconsistent log format defined, or you are not structured in the proper. So it is going to be difficult to parse your data, and you can how you can analyze if it is difficult to parse that. So there are you can let's say you are using this particular service, and then you see you are trying to log that information in an improper way. So what you have to do, you have to use a structured format like JSON logging that is using the logback or log4j, or there are some libraries like logstash which is going to give you a proper key value pair way of parsing it. So if you have to just define the dependency, and then the configuration has to be defined for it, and then you can make use of that particular logger, and you can use this particular format over here to add it. So in this case you're trying to properly add it in a concise way. Or let's say you're trying to expose some lack of some health metrics, so you're not exposing the actuator endpoints which we already discussed. So try to expose only those specific and the required things in the application. So here you can define there is a health related indicator. If you want to do some specific configuration related to that, you can override this particular custom matrices defined for the health part, and then you can define your logic over here, and you can expose that. Then towards the end you have this particular testing things. So you are trying to over rely on the spring boot test. So this is going to be a problematic. So if you're trying to overuse it, so this is going to make your test suite slow. Also there are a lot of integration and the unit testing that has to be taken care. So you try to load your application context over here. So this is going to be lot I mean, I would say a lot much loaded on this. So instead of that, you can make use of the different annotation, web MVC test or data specific, which is going to load specific only the relevant part of your application context, not the whole application context to what you have done similarly here. So it is going like instead of loading everything over here, right? You are trying to do specific things over here, like web MVC. In that case, it will reduce that particular load on the system. And then you have some inadequate mocking, so you're not trying to effectively mock your external dependencies like database, external APIs, etc. So you have to make use of that in a proper way. So if you take a look at this, the REST template, you're trying to do the testing over here. You have the Spring Boot test defined over here. You're trying to do the testing. So this is going to be a little bit slower over here. Now instead of that, you can mock your using the Mockito. You can use mock beans, REST client test. So it will isolate that particular code under the test for external dependencies. That's how you define that. Now if you see here, you're trying to load only the web bean over here instead of loading all of them. You're trying to test that particular specific methods over here. Alternatively, you can write your REST related testings over here. So in that way, you are writing specifically and loading these things, and also specifically trying to test that only instead of loading everything and testing everything over here. So that's all for this video. I hope I was able to explain you common pitfalls and also the code review comments which you need to address them so that you doesn't get the code review comments in the PR. So if this video was helpful, please share it with the needy people. Also, don't forget to like, subscribe, and hit the bell icon. Thank you for watching.